Okay, so we are going to types of dimension. I said we have dimensional variable, we have non-dimensional variable, we have dimensional constant, and we have non-dimensional constant. Now, what are dimensional variables? This thing is very important for you to understand dimension so that you would understand how to, when we are talking about homogeneity and how to get dimensional formula, you understand these things will come in handy that period. So what are dimensional variables? They are variables that have dimension. So almost all the quantities, when you say something is variable, that means it's not constant. Something, a quantity can either be constant or variable. Variable means something that is changing. Okay. So when I'm talking about dimensional variable now, I mean something that is changing that has dimension. For example, now when you talk about force, force can be 5 Newton, can be 10 Newton, can be 20 Newton, so it's changing. But force also have dimension. Okay, so dimensional variable are variable that has dimension. Example: force, acceleration. Almost all the quantities that you know are dimensional variable. Okay, so the second one is non-dimensional variable. So non-dimensional variable as variables that is changing, as I said, but that does not have dimension. Variable that changes but does not have dimension. For example, now we talk about strain. Okay, strain. The reason why strain does not have dimension is that strain is what? Extension over length. So extension is a meter, length is a meter. So to cancel each other. Remember the question we asked the other time, that is it possible for something not to have dimension and unit? So example of this non-dimensional variable are example of quantity that has no dimension and does not have unit. Is an example. They don't have dimension, they don't have unit. So this non-dimensional variable is an example of quantity that does not have dimension and that does not also have unit, because their unit cancel. For example, now coefficient of friction is frictional force over normal reaction. It cancel. Mechanical accuracy, load over effort. It cancel. Okay. Velocity ratio, this time by effort over this time by load. That also cancel. So example of all these things are non-dimensional variable. They are variable, they change. Question start, when you are doing your physics question, your coefficient of style friction can be 0.2, it can be 0.3, it can be 0.4. It changes. So they are variable that change, but they don't have dimension because their dimension cancel. Now the third one is dimensional constant. Okay, they are constant, they don't change, but they have dimension. Example of dimensional constant are, we will talk about gravitational constant, which is 6.67. Okay, that steps to minus 11. Yeah, that steps to minus 11. Okay, talk of Planck constant, we talk of Boltzmann constant. So all these constants, they are constant, but they have dimension. We'll still do the dimension of constant. We'll get the dimension of constant. All these constants now, we'll do the dimension as we go in this class. So the last one is non-dimensional constant, something that does not have dimension and it's also a constant. It does not change. It does not have dimension. It does not change. For example, we talk about pi. Pi does not have dimension. For example, pi is 3.14. Okay, it does not have dimension and is a constant. Okay, pi does not have dimension, it's a constant. Another thing is pure number, like 1 is 1, 2 is 2, 3 is 3. They don't have dimension and they are still constant. 1 cannot change, 2 cannot change, 3 cannot change. Do you understand? So now we have treated 4 type of dimension. Okay, we said we have dimensional variable, non dimensional variable, dimensional constant, non dimensional constant. Now let's go to dimension. So this dimension, this one that we want to do now will be the part 2 of the video. So we are going to dimension. So we are going to be doing it in 2 ways. We'll look at how to get dimension of 3 ways. Actually, we are going to do it in 3 ways. The first part is how to get dimension of quantities. Second part is homogeneity. Third part is how to derive formula using dimension. But if you are a UI student, the one that you necessarily need is the first two: how to get dimensional formula for how to get dimensional formula. Okay, and two is how to use homogeneity to get dimension. So the last one of deriving didn't does not really come up in UI, but actually we'll do it so that you can see um, everything together. So thank you so much.